Hello and welcome to this video. My name is Martin Mwenda Kimathi, one of the Kenya Live Program GMAT trainers. This video is part of a series through which we share some of the techniques and strategies that we encourage our students to use when they are trying to handle the GMAT exam. And in this video, I'll be focusing on the permutations topic, which is one of the essential topics in the GMAT Quant, particularly because of the way it's tested in isolation, as well as how it's tested in combination with other topics, more so the probability topic. And the value of this topic is that it enables one to become more efficient because it offers a means to arrive at the required values or to perform certain computations without requiring to do, lengthy processes. Yeah, you just need to perform, say, two or just one computation, and which would in most cases be a factorial, and then you end up getting the required answer rather than going the long way, which is particularly so when you use the conventional means of solving some of the probability problems. So on to the first question that I'm going to cover in this session. It's arguably a level 550 question, and its classification in this class or this level is just based on my analysis on the number of students who do get it right. So the question is, in how many ways can we arrange the letters of the word solution such that the vowels always appear together? So just from the word rearranging the letters, we can tell that this problem requires us to do permutations, because permutations are applicable when we're trying, to arrange elements or items, say in a row, in a circle, or in any form of arrangement. And of course, the arrangement doesn't have to follow any particular order. You can have, in this case, we could have S beginning, as it is in the word solution, followed by any of the letters. And we can also begin with any other letter, and the different arrangements, they can follow any particular order, right? So in this case, the elements or the units that you're going to be arranging, one is the vowels, and two is the consonants. And since we are told that we want the vowels to appear together always, then it means we can consider them as one unit. Yeah, and in this unit of vowels is going to contain 1, 2, 3, and 4. It's going to contain 4 letters, but we are going to consider it as one unit when you're doing the computation for the number of ways of arranging the units in these two classes, right? Then the consonants, you are not required to, follow any order in the arrangement, in that they can either appear together or they cannot, right? So then these are distinct units, and the consonants are 1, 2, 3, and 4. We have 4 consonants. And since they are all distinct, in that we are not required to arrange them together, then we can look at them as 4 units. So in total, we have 5 units which we are required to arrange, right? So the means of arranging is just doing n factorial so that you can arrange them. So in this case, you would have 5 factorial. However, among these 4 letters, we have to find a means of arranging them. Yeah, and we notice that we have 1 and 2 letters that are not distinct, okay, in that they are repeated. And that's to say then that we can't, if we are to arrange them as the first O and the second O, there is no way of differentiating them, that this was the first, this was the second, such that then we have to find the means, you know, of taking care of this scenario where we can't differentiate the two letters. And so then we are going to have out of this, to have 4 factorial divided by the number of non-distinct letters, and that is 2. We have 2. So this operation, the value of this operation is to take care of this situation where we have 2 non-distinct values or letters, which we actually can't consider them, you know, to be a unit in themselves, because there's no way of differentiating the first one with the second one, such that then if we're able to differentiate them, then if these, say we would have a marker, those to be the markers, then we would say if you are to have a different arrangement, we would have this. But then since we can't, you know, we can't differentiate the 2 of them, it means then we have to find a way of taking care of that situation, that unique situation. And so then to find the number of ways of arranging these 8 letters such that the vowels always appear together, we are going to multiply these 2 computations, so that we have 5 factorial multiplied by 4 factorial over 2 factorial. And this gives us the number of ways of rearranging the letters and ensuring that the vowels always appear together. Okay, on to the second question. So this question, the question states that set A contains distinct integers, that is 3, 5, P, 9, minus 8, Q6. Remember that you're told that these integers are distinct. This is the first keyword that you need to note. Then when 3 numbers from this set are selected and multiplied, what is the probability that the product is negative? So if we were to come into this set and select 3 values or 3 numbers, and remember that these 3 numbers are distinct, and perform a multiplication, then what is the probability that that multiplication is going to yield a negative product? So since we asked for the probability, yeah, this is one of the key points that we need to note from this question stem before going ahead to analyze the statements, and it falls in the first step of handling data sufficiency question, which is asking what type of question are you faced with. In this case, it's a probability question and it's a value question. It's a value problem. And this means that we are required to find the value of the probability of the product being negative. So then, since now that we already know what we are required to do, we can move on to define sufficiency, which then will tell us what we would be looking for in the statements to determine whether they are sufficient or not. And since this is a value problem, then it means that we need to get a specific value for this probability, for the probability of the product being negative for any of the given statements to be sufficient. So that means that for any of the 2 statements, that is A and B, or the 2 of them together, for them to be sufficient, they must help us to get a specific value for the probability. And this goes without saying that if any of the statements were to give us, you know, multiple values of the probability, then that statement becomes insufficient. So then with that information, you can go ahead to analyze the statements, and we begin the first one. You're told that the product P times Q is non-zero. So then this means that none of, it means that looking at A, it means that P is not equal to 0 and Q is not equal to 0. Yeah, so the 2 values can never be 0 since their product is non-zero. But we can also deduce from this that P can either be positive and P can either be negative. And the same applies to Q, that Q can be positive and Q can be negative, right? So then if we were to evaluate the probability of the product of three integers out of this set being negative, we would have, say, we consider in the first case that P is positive and Q to be positive, then of course we would have one of the values being negative and it's the only value that we'll be considering. Yeah. And of course we would get a value for the probability. However, note that this value, we would expect that this value is going to be different when P is negative and we take any other combination of the possible values of Q. So then this means that we have multiple values for the probability of the product of the three integers picked from this set being negative. And for that reason, since we define that for sufficiency, that sufficient statement is going to give us one unique value, then this statement becomes insufficient. And for that reason, we have to follow a decision tree. And for that reason, then we cancel out choice A and choice B, which ideally would mean that statement one is sufficient. So with that, then we can go ahead and look at the second statement, which states that the absolute value of P is equal to the absolute value of Q. And from this, we can deduce that the only situations where we would have the absolute value of P being equal to the absolute value of Q is when we have P to be equal to Q, or when P is equals to the negative of Q. Yeah. So these are the two situations where we would have the absolute value of P being equal to the absolute value of Q. Then remember that the question time specified that you're only looking at distinct integers. So then it goes without saying that this one cannot be possible for this case, because we're only looking at distinct integers, and when P is equal to Q, then it means that these two values are not distinct, they are the same. So we are left with just one possibility where P is equals to negative Q. Yeah, and of course, since you're left with only one possibility, then it goes without saying that we can actually find a specific value for the probability of the product of these integers being the product of the three integers picked from this set being negative. And of course, for us, this question isn't directly the permutations question, although it follows from the understanding of permutations that it's only through permutations that we could, that permutations is one of the strategies that can help us to actually calculate this probability, because, you try to find different combinations of these integers and then find the different ways that, we can combine them so that then we can get this negative product, all right? So since we've identified that there's only one possibility where P is equals, where the absolute value of P is equals to the absolute value of Q, we can tell that we can find a specific value for a specific value for the probability. Therefore, then choice B becomes our correct answer, right?
You're watching Success with Bob Mwiti Show, presented to you by Appstech America. Appstech America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.appstechamerica.com. Appstech America, we wake you up to the unlimited potential within you.
So you can, on the next question, which is the final question, this question states that in how many different ways can the employees of a company be arranged in a row if no two people of the same gender can be adjacent? So remember that from the first question, we looked at a situation where there were two we wanted to have the vowels together. So in this case, we don't want people of the same gender to be adjacent. We just want to find a situation where, if we are to arrange them, we would have a male employee followed by a female, followed by a male, followed by, they are alternating. We don't want to have anyone of the same gender adjacent. And on the first step of solving this data sufficiency question, we would want to identify the type of the question. And since you asked about how many different ways, we can tell that this is a value question, just like the previous one, because it needs us to find the number of ways that the employees can be arranged such that they meet this condition. Okay, so then our definition of sufficiency is that a sufficient a statement that is sufficient actually gives us helps us to find a specific value for the number of ways of arranging these employees, right? So then when we begin analyzing the statement, we are looking for one that helps us to find a specific value for what is required in the question statement. So onto the first statement, it states that the number of women employees is greater than the number of male employees by 2. So this means that if we were to take the number of women to be X, then the number of men would be that the number of women employees is greater than the number of male employees by 2. So then this would be X minus 2. You would have X minus 2 male employees. Okay, so then does this statement, how we ask ourselves whether this statement helps us to find a specific value for the number of ways of arranging these employees and meeting the condition, right? So since we've just let the number of women be X, this value of X can take any of the numbers, any of the value, the real numbers, and of course integers, because we can't have half a person, and also we can't have a negative person. So then this would take any of the values 0 all the way to infinity. And then this means then that the number of men also is going to fall in this range. And of course, since then, since the value of X falls in this region, it goes without saying that, we can take so many values, which of course then are going to yield so many different ways of arranging the people. And for that reason, then this statement does not fulfill our requirement for sufficiency. And then it becomes insufficient. And then we have to cancel out choice A and choice D, because the first statement is insufficient, and its insufficiency follows from the fact that we have so many values for the women as well as the men, which then means that we can get so many different ways of arranging the people in a row. And the requirement is that we need just one specific value for this number of ways of arranging the people. So then you go to the second statement. It states that if only the male employees were arranged, you'd get this number 479,001,600 different arrangements that would be possible. Yeah. So we have a number of the different arrangements that would be possible if we were to only consider the male employees. So we go back to our understanding of permutations, and this guides us to tell that the number of ways of arranging these people is n factorial. Yeah. So if we are to perform this factorial, we would get 479 million and 1,600. Yeah. So from this, we can deduce the number of male employees, because if you're able to find this value whose factorial is 479 million 1,600. If we are to get this value of n, then we can actually get the number of male employees. Of course, this in the exam setup, this is a difficult, or it's an impossible operation to perform if you actually don't know the number whose factorial is this, and you can't, of course, you can't go, doing the trial and error method. Actually, you don't need to do the actual permutation, because in understanding, you can tell that there is a specific value whose factorial is going to give you this. Yeah, and since we have that value, we can tell that there is a specific value which can give us this number of different arrangements, then we can deduce that we can get x, because we know that the number of men, which is n, is equals to x minus 2. So then x, okay, before that, before doing this combination, we would only, the second statement would only help us to find the number of men. It doesn't help us to find the number of women. And since the question stem requires us to find the different ways of arranging these employees, then it would become insufficient, because it doesn't help us to find the number of women. Yeah. So an addition to our definition of sufficiency is that for us to get this specific value of the number of ways, we would actually need to get the number of men as well as the number of women. So since this statement only gives us the number of men, it's actually insufficient, because it doesn't give us any means of identifying the number of female employees. So then, following from that understanding, then we can term this statement as insufficient, and then choice B becomes we can eliminate choice B, and then we are left with C and E, which we only consider when we have to combine the two statements. And then in combining the two statements, we would need to meet these two conditions, that if we are to arrange the male employees, you would expect that you're going to get n factorial to be this value, which then means you can get a specific value for the number of male employees. And then we would want to have to meet this condition where the number of women employees should be greater than the number of male employees by 2. So then from that is what I was alluding to here. We can actually get the number of women, since n, which is the number of male employees given by this operation here, is equal to x minus 2. This is what is defined in the first statement. Then we can get x to be equals to n plus 2. So if we are to get this value, if we are to get this value of whose factorial is 479,001,600, if we are to get this value, we would actually get the value or the number of women. So then from that, we can tell that there is a way of finding this specific value of the number of ways of arranging the employees of this particular company, because we can get n from this operation. Of course, it's not practical in the exam, but in understanding, you can actually tell that this value of n is a value that you can actually get if you are to do the computation. And of course, just for specificity, this value of n is 12. Then since 12 factorial gives us this, we can actually get the value of x, which would be 14. And of course, now we will be arranging, you find a way of arranging these people, since you already have all that is required of us for the statements to be sufficient. And since we found the sufficiency by combining the two statements, then our correct answer choice is C. Okay, I hope everything was clear in this session. And I would employ anyone who is watching these videos to reach out to the Kenya Life program and sign up for our GMAT training. You're going to benefit tremendously from the value we have to offer you. Thank you.
You've been watching Success with Bob Mwiti Show, brought to you by Upstack America. Come back next time to hear more steps and missteps that I took on the path to becoming a successful immigrant in USA. Be sure to subscribe to my YouTube channel and also follow me on Facebook, Instagram, Twitter, and LinkedIn.